Good morning, good afternoon, everyone, and welcome to our 2024-2025 Winter Weather Outlook webinar. My name is Andrea Berg, and I will be your host today. I just want to go over a few housekeeping items before we get started. I am recording this webinar, and the recording link will be sent out to everyone who registered for this webinar when it's available. Please contact me, the host, if you are experiencing any technical difficulties during this webinar. You can message me through the chat feature. And we have reserved some time at the end of the webinar to answer any questions you may have, but please feel free at any point during the webinar to put those questions in either the chat or the Q&A feature. So I am going to turn this presentation over to Eric Jenks, who will kick us off today. Eric?
Thank you, Andrea. My name is Eric Jenks. I am a weather risk communicator on the long range team here at DTN, and I have been working in the forecasting industry for over 11 years. Joining me today will be Nate Hamblin, who is also a weather risk communicator on our long range team, who has been in the business for over 20 years. And then finishing things off will be Steven Strum, who is the weather risk senior manager on the long range team, who has been in the energy and trading industry business forecasting over the past 25 years. Taking a quick look at the agenda for this presentation, we will start with a quick review of last winter during the 23-24 season. Then after looking at that, we will move on to our forecasting techniques, looking at El Nino and different analog patterns that can help shape what's occurred in the past and may be assigned to what could occur this year. And we'll also look at polar vortex outlook, that what could potentially occur this winter. And then we'll also combine that with our computer model projections, our dynamical models using current ocean and atmosphere observations. And we'll wrap all that together to put together our DTN seasonal outlook between November and March of 24 to 25, with a little bit of a look at our heating degree outlook and a look back at previous winter outlooks in terms of verification. And we'll wrap that up into our industry impacts, looking at utilities, aviation, transportation, and the offshore industry. So we'll start with a look at last winter, the highlights that occurred. And the big feature note was from last winter was our strong El Nino that was in place throughout the winter with the warmer waters off the Eastern Pacific along the equator. And that helped generate a stronger jet stream across the southern US and the Gulf of Mexico, as highlighted on the image to the right in the yellows, oranges, and reds, with a weaker jet stream to the north across the northern US and southern Canada in the blues and the purples. During last winter, we had well above normal temperatures throughout the majority of the winter across the north central and the northeast US. We did have a short-lived Arctic cold shot that it did occur during mid-January that impacted the northwest US and extended through the central US. That lasted for about a week or so. That was really the only true interruption, though, to the warmer winter that occurred last year. In terms of precipitation, we had a wet overall winter along the eastern seaboard, the Gulf Coast, as well as along across the southwest US, with snow generally heavy at times across most of the west, especially the interior southwest and through the Great Basin. Below normal snowfall was widespread across the majority of the Northeast, the Midwest, and the Northern Plains. So looking at the winter in totality, on the left we have our temperature departures, and you can see the majority of the US was above to well above normal temperatures throughout the winter, with the warmest anomalies in excess of 5 degrees above normal throughout the winter, from the Northern Plains through the Great Lakes, and then also extending towards interior sections of the Northeast. Warm anomalies were not quite as robust in the Southwest as well as along the Gulf Coast throughout the winter. Precipitation is on the right, and the blues indicate the wetter conditions and the reds are the drier conditions, and you can see up and down the East Coast and along the Gulf Coast above normal precipitation throughout the winter months, and then as well as across much of the West and the Southwest, especially along the coast of California and Oregon. Our drier sectors were more across the upper Midwest and then through the mid-Mississippi Valley into the Ohio Valley and Tennessee Valley in particular over the course of last winter. Narrowing in now on to each individual month, and you can see November do have some cooler anomalies that lingered across the Northeast early winter, with the warmer anomalies generally across the western and central U.S. But as we moved into December, it was above to well above normal temperatures across the country, especially across the north central U.S. January, you see the impact from our one significant cold push that occurred in mid-January, with cold anomalies across the Northwest and then through much of the central U.S. This did not quite get into the Great Lakes Northeast region, where warm anomalies did continue, as well as it did across California. February, our very warm winter returned across the central and eastern U.S. and most of the Northwest U.S. as well. It's just Southern California into Arizona that mostly missed out on the warmth in February. And then March, the eastern half of the U.S. was quite warm, especially the Great Lakes and the Northeast, and then near to below normal temperatures in the West, with coolest anomalies across the interior West. Looking at our precipitation, and you can see November was quite dry across much of the central and eastern U.S. aside from the Florida Peninsula. The wettest conditions generally focused across Pacific Northwest into northern and central California. By December, we started to see our wet signal emerge along the East Coast, with dryness across much of the central U.S., especially away from the Gulf Coast and West Texas, with wetter pattern across the western U.S. January, widespread wet conditions across the south and the east and much of the country. Really, the only real dry areas were across Southern California and then portions of the northern plains, upper Mississippi Valley. February, wet conditions shifted towards the western U.S. and mostly dry across the east, aside from near the Gulf of Mexico and the Florida Peninsula. But March returned to a quite wet pattern across the south and the east, and really much of the U.S., with aside from Pacific Northwest and the upper Mississippi Valley. Our snowfall totals and anomalies from last year are totals on the left and the anomalies on the right, with the grays indicating below normal snowfall and the blues indicating above normal snowfall. And you can see much of the central and eastern U.S. below normal snowfall, outside of a few isolated spots here or there across the interior Northeast or across the Central Plains. Where we saw our above normal snowfall was across the Intermountain West, especially from Oregon and Northern California through the Great Basin and towards the Four Corners. Now we'll look at more recent trends, and this is looking more at the late summer into the start of fall. And you can see well above normal temperatures overall throughout the 3-month period. That's mostly being driven by September and especially October across the desert Southwest and through the central U.S., where there are major warm anomalies taking place. Many record highs have fallen in these regions over the past couple of months. August was not quite as warm across the upper Midwest. You do see a little bit of a pocket across Minnesota, Iowa, towards Kansas City, where it was more seasonable overall. We did have some cooler anomalies along the West Coast near California. As we've gotten into September and October, the warmth has not been quite as robust along the East Coast, but warmer anomalies have generally taken hold in those regions as well. Precipitation-wise, we did have a wet end of the summer along the East Coast, Florida up through Mid-Atlantic and New England, and then as well as across the Pacific Northwest, but generally drier overall South Central U.S. through the Great Lakes. And then as we've gotten into September and October, it's been a quite dry pattern aside from the impacts of Hurricane Helene and Hurricane Milton across the Southeast. And you can see that reflected with the robust precipitation in September across the Southeast. And then as we get to October, it's majority dry aside from the southern half of the Florida Peninsula, but well below normal precipitation otherwise from Texas through the remainder of the eastern U.S. When is the coldest 90-day period of the year in the U.S.? And you can see on the map on the top left there, the oranges indicate where the coldest 90-day period occurs earlier in the late fall, generally during mid to late November, and then the blues in the Northeast are when the coldest 90-day period begins later, looking more early to mid-December at that point. And you can see 90-day period begins and ends later in the Northeast compared to the South and the West during most years. And then we have our 10-year trends going along the bottom there, December, February, and March. And you can see December is generally a warming trend for much of the U.S. Compared to what we generally see in December, especially across the Central Plains through the Mid-Atlantic. Not quite as strong of a signal as you get towards the Northwest and the Northern Plains. February, you can see our 10-year trends have stronger cold signal across the central U.S. in February and into the Northwest, with warm anomalies in the Southwest and modest warmth along the East Coast. And then some lingering coolness in March across the Upper Mississippi Valley and Great Lakes, with a warmer general trend across the west and the south central US. So generally, polar temperatures have arrived later in the past 10 years on average, and lingered a little bit longer into the spring across the north central US and the Great Lakes. And with that, I will turn things over to Nate, who will take a look at our seasonal forecast process. Take it over, Nate.
Thank you, Eric, and welcome everybody. Let's get into our winter seasonal influencers. And ENSO is usually the biggest contribution overall, especially when it's strong. 40% of the season is typically influenced by ENSO, sometimes more, sometimes less. And we have pretty good skill at forecasting that and its associated impacts. But then polar vortex, you've heard about that in recent years. That can be upwards of 30%, especially if there are disruptions. And we have fair skill at determining years where there's probably going to be a disruption, but it's a little bit more difficult to time it out. Those are usually more of a subseasonal influence. And then other subseasonal influences like snow cover or the MJO, Madden-Julian oscillation, those types of things usually can be 10%, sometimes a little bit more, sometimes a little bit less, depending upon how active they are. And we have pretty low skill from a seasonal standpoint of timing them out. And then, of course, we can see what has happened in recent years, our 10-year trends, 5-year trends, and things like that. So we have pretty good skill, at least knowing what happened. So our main seasonal drivers, if you look at the sea surface temperature map on the right, it will show them very clearly. See all the blues, the below average temperatures west of South America during the winter season. That is our developing La Nina that is forecast to get going and peak in the late fall and last through the winter season. And then our other one, the minus PDO, the Pacific Decadal Oscillation, and basically what that means is that there's warm water in the North Pacific, but cooler water right along the west coast. So that is the negative or the cooler phase of the PDO. And then you may have heard all this warm water in the North Atlantic. That's not going to end anytime soon. So that is forecast to continue. So the warmer Atlantic multi-decadal oscillation. So what we like to do is look in the past for years that had similar ocean temperature profiles, something that's close to this, and that can give us some clues on where things might be leading. And if we go at the ENSO forecast overall from different modeling centers all across the world, the thick red line is going to be the model average, and it's a weak La Nina being shown just over the threshold of minus 0.5 degrees Celsius below normal. Most models are right around that point. There's a couple that are a little stronger and a couple that are in the neutral camp. Those are outliers. So I think there's enough confidence to say we'll have a weak La Nina that'll peak kind of later in the fall and then gradually weaken as we get towards the first quarter, especially the second quarter of 2025. So trying to see if we get some clues on what the pattern's doing now and what that might do during the winter season. So just using September, for example, if you look at the map on the right, what is verified, these are 500 millibar flow height anomalies, and you see all the red numbers or red colors in the eastern part of Canada and the central part of the US. That's where ridging is, and see the blues in Alaska through Siberia. That's a trough. So what I did was we broke it down into warmer and cooler Octobers, especially in the central part of the country, and the warmer ones had 500 millibar anomalies like the ones on the left, and then the cooler ones were in the center. And to me, it looks a lot like the warmer scenario that what happened in 2024. And sure enough, October turned out pretty warm. So can we use October as a winter predictor? If we took those same years and we rolled it out for the December through February forecast, the warmer Octobers tend to lead to these warmer winters. So above average central and eastern US, a little cooler along the west coast of US and Canada. However, the cooler Octobers had a little bit of an opposite signal. A lot of cold in the central part of the country, bleeding into the east, with the only warmth in the southwestern part of the country. And notice all the warm colors in Alaska and Greenland. So more of a blocked up pattern. So right now, everything is acting like the winter's going to come in a little bit warmer. Of course, if it was that simple, this would be an easy science. So we have to look at other things. Taking a quick look at precipitation, the warmer Octobers tend to lead to a little bit of a drier overall outlook from the mid-Atlantic through the south central and southeastern part of the country, above average precipitation in northern New England along the Canadian border, and especially along the west coast of the US in British Columbia. The cooler scenario has a lot drier look on the west coast, so it makes a lot of difference there what happens. In the east, it's a little bit wetter overall in the Midwest through New England, and then drier in the southeast. So again, looking like that warmer scenario at this point, so a little bit less precipitation potentially in the east and south. So let's take a look at some analogs, which are weather conditions from previous years with those ocean temperature patterns that we just talked about. And our analog list is shown on the right. Our top 10 years, 2021, 2022 being number one, and pretty much we cover all the possibilities, a little bit of a stronger La Nina and a weaker neutral. So covering some of the outliers, but pretty much everything there is a weaker La Nina. So they fit the bill from an ENSO standpoint. And sea surface temperature analogs from December through February, note the cooler sea surface temperatures west of South America in the ENSO region, the warmth in the Atlantic, and then that warmth in the central North Pacific, and the cooler water along the west coast. So I think we have those bases covered relatively well, with some variability, of course. Jet stream analogs. Eric showed you what happened last year. This year, the forecast is to be mostly the opposite. Note all these colors, the orange and yellow in the northern half of the US. That is where the stronger jet stream is forecast to be. And that's usually where the storm track ends up, somewhere in there. And going down into the Gulf of Mexico and along the southern border, you see the purple blue colors. That indicates a weaker jet stream. And usually there's less precipitation, less storminess in those areas. So let's take a look at some of the analogs and for month, and for November, no surprise, a lot of warmth being shown, especially in the central part of the country, but no real cold, at least a monthly standpoint anywhere. And then precipitation, a continuation of the drier pattern across the south and east, but the northwestern part of the country should be active, and then we should get a little bit going in parts of the central plains through the upper Midwest. December, another warmer look central and east, but some cooler air starts to get working into the pattern in the northwestern part of the country and into western Canada. And precipitation, again, another dry outlook for the east and south, but nearer to slightly above average for most of the northwest and along the Canadian border in the northern plains and the southern Canadian prairies. January, this looks very warm from the analog standpoint. Central and eastern part of the country starting to look like that warm October winter look, with a little bit cooler along the west coast. And precipitation starts to pick up from the mid-Atlantic, southern New England into the Tennessee Valley, and then the Pacific Northwest. Other than that, dry along the southern border, and then a little bit drier in the upper Great Lakes and the upper Midwest. February, see a little cooler air sneaking a little bit further eastward. So note the idea that some late winter cold is not out of the realm of possibility. Above average in the east, especially east of the Appalachians, and then below average temperatures northwest, south central, and then a little drier look southern U.S., and then the Great Lakes, northern New England, and in the Pacific Northwest above average. And then the end of winter period, March, slight warm signal in the east, slight cool signal in the west, some variability inferred there, and then a little bit more active from the Arklatex region to the upper Great Lakes, upper Midwest. Wrap that up for December through February. It looks just like that warm October period, above average central east, below average northwest. Precipitation, a little drier outlook, with the exception of the Pacific Northwest, and then the Ohio Valley and the Great Lakes near to maybe slightly above average. What does La Nina do to snowfall? Well, all La Nina years, weak La Nina years and strong La Nina years are separated in research linked below, and the primary impact is more snow across the northern U.S. with a stronger jet stream. That makes sense. But when we separate it into weak and strong, the weaker the event is, usually the further south you can get some snow. So you start to see above average snows creep into the central plains, into Illinois, Indiana, Great Lakes, and more of New England and the northern mid-Atlantic. Whereas if you have a stronger event, you see the browns in many of those areas, and everything is all that snow is tucked in a lot closer to the Canadian border, and you could get even more snow across Western Canada and the Pacific Northwest. So using our analogs we talked about earlier, here's our top 6. And you can see the variability involved. The blue is being above average snow, the gray is being below. There's a lot of territory of below average snow, especially 05, 06. But there's also some pockets of above average. So the ones in the 2020s getting into the south a little bit, and that's very well possible. So it's not as if we're going to be devoid of snow, but note the Northwest in general is favored more than most other places. Let's bridge into the polar vortex here real quick. And the strong polar vortex is one that is more circular. Note the example on the left keeps colder air contained with a strong westerly jet stream flow. But if it weakens, that means that you get a little pieces that can break off from the vortex and come southward, and the jet stream becomes a little bit more wavy, and it kind of guides where this cold air goes. So extreme cold can follow the vortex. Now the details, usually we can't get until under 2 weeks, but from a seasonal standpoint, we can kind of get an idea how this season might go in terms of if there's going to be a sufficient polar vortex disturbance to bring down cold air and disrupt whatever ongoing pattern there was. So how do we determine that? Well, we take a look at a couple things here. This year we have a unique situation. We have the positive QBO, which is the quasi-biennial oscillation. And basically what that means is westerly winds that are strong in the stratosphere over the equatorial region. Note the red colors there, zonal winds. So that picked up some years that had a positive QBO, and then in the center we have our solar cycle, and there's a lot going on. We're out near solar max right now, so there's been a lot of sunspots on the sun. You know, all the northern lights this year. That's part of it. So we are near solar max. So I took years up that we're near solar max and had a positive QBO. And if we look at the graph on the right, you note the red colors right around 60 degrees north across Canada, Europe, Russia. And that is indicative of a stronger polar vortex overall. So most of the season, this implies that we'll have a strong polar vortex. But there is a risk of disruptions, and we'll talk about that right now. Breaking it down by month, December and January, note a strong polar vortex centered about the pole. So it might take a little bit to get it going, but by the time we get to February, note it starts to move around. It comes off the pole a little bit, even though it's slightly strong. And then in March, check it out, all those yellow and red colors tend to disappear and we become purple. So that kind of weakens a bit. So what this tells me is that there's going to be a risk of at least a late season polar vortex disruption. We'll have to watch it. And if that happens, that can lead to colder air masses that can come down late in the winter as implied on some of the analogs, or even the delayed spring warming. We'll have to see about those details because it depends on the nature of each polar vortex disturbance. So let's move on to the weather models. We'll compare what the analogs had to say to that. And for the next few months, the ECMWF model we'll start with, and on the left, temperatures, on the right, precipitation. And there's all kinds of warmth to be seen in November and December, especially across the central part of the country. January, warmth across the south and east, but note some of that colder air trying to creep in to the northwest and then into the northern plains. So that will be something that we'll have to watch out for. And then precipitation, dry across the east and south in November, a little bit more active in the north central and northwest. And then December and January, you start to notice some precipitation increasing further south than what the analogs had to say, across the lower Mississippi Valley up through the Ohio and Tennessee valleys, and then above average in the northwestern part of the country, and then generally across the the Great Lakes and the New England. So slightly wetter from this model. And then February, March, generally above normal across the southern U.S., but note the idea that some coolness can get a little bit further south, at least into the northern part of the country. Models do indicate that. Precipitation for February, March, above average in the northwest, above average in the Ohio and Tennessee valleys, and a little bit drier along the immediate coastline in general. And then just for a quick April preview, a little bit warmer in overall, and then a little bit wetter in the south and east than what the winter has shown. Let's compare that to the CFS. Well, the CFS shows that significant warmth. That matches the analogs very well. Of course, the dry weather November matches relatively well overall, but in December it is also very warm and then dry south and wet Great Lakes, northern New England, and the Northwest. And then January, this is where it starts to differ. Note the cold air starts to come a little bit further south than the analogs in the ECMWF, although the warmth stays in place in the south. And then a lot more precip in the Northwest getting into the northern plains. In February and March, the cold air is lurking in Canada. That's what it's trying to say. Some of it could come south if it had the right mechanism to do so, but it does show at least the potential for some late season colder air. And then warmth centered across Texas. And then you see it picking up in precipitation, a bit more active in the Northwest and the northern US in general, with particular focus from the Ohio Valley to the Great Lakes. And then April, warm south, cool north central Northwest, and a very active overall. So delayed spring could be indicated by this model. So with that in mind, I'm going to pass it over to our leader, Steve Strum, to tell us what it all means and wrap it up into a forecast. Take it away, Steve.
All right, thank you very much, Nate. And we'll go ahead here and basically take all those indicators and drivers of the pattern and combine that into our seasonal outlook, as well as adjusting things for trends in recent years and so forth to come up with our final forecast, at least to this point in the season, for the November to March period. So you can see here the month-by-month basis here, for the most part, dominated by warmth in many areas of the country. But notice, again, we do have that potential for more cold showing up across the northwestern third of the country from December into January, and then potentially becoming a little bit more widespread during the month of February. Overall, February does have the highest risk for seeing a more widespread outbreak of colder air across the country. And then possibly receding a little bit during the course of March. More than likely, we will see a week or two of widespread cold develop at some point, especially during the second half of the winter season there. Timing that exactly is obviously hard to do this far out, but even though we do have most of the eastern half of the country forecast to be warmer than normal for the winter season in most months, again, we are likely going to see, that period of colder air develop at some point during the season, most likely during February, but it could happen during the first half of December too. We'll have to kind of see how that plays out. But kind of like last year, where it was a very mild winter, but we did have that one, 7 to 10 day period during the middle of January that did bring a lot of cold. And so La Nina winters do tend to see a lot of intense Arctic outbreaks historically. Even during the mild winters, it's not uncommon to see a week of really cold air develop. And so again, that's more likely late in the winter this year, but we cannot fully rule it out for December either. When combining the winter months together of December through February, you can see the overall tendency for a warmer than average pattern across the southern and eastern US, colder north and west, and the southwest and the southeast especially have the highest probability of averaging warmer than normal. Now, on a heating degree day standpoint, this winter season does look to end up, as you would expect, with below average HDD totals, so below average heating demand. But note that compared to last year, it's still quite a bit higher than last winter. But obviously, last winter was one of the warmest on record, so not a high bar to clear. But nonetheless, still, even with our colder scenario for this winter season, at best, kind of a more seasonal average. And keep in mind, with that cold scenario, there would likely be a month or more that did see a lot of widespread cold, but considering the very warm November that's expected and likely at least one other very warm month during the winter season, it is going to be hard for the entire November to March period to average colder than average. Now, our warm scenario is even warmer than our current forecast, with strong warm anomalies across the eastern half of the country compared to our current forecast. Our cold scenario, though, does show more widespread cold across especially the upper Midwest instead of just the Northwest. And so that is the area that does have the higher risk to come in colder than currently forecast. And part of that will also depend on how snow cover evolves as we progress through the winter season. If we do build up a lot of deep snow cover early on in the winter season across those areas, that will tend to reduce the amount of warming that takes place and make it easier for those stronger cold anomalies to develop during the remainder of the winter season. So we'll have to watch the snow cover expansion as we progress forward through the first part of the winter season. But overall, that is the area to look for a potential, at least, of a colder than forecast outcome relative to other parts of the country. The East Coast still likely to end up warmer than normal for the winter season regardless. as well as across the Southwest. Now, looking at the heating degree day totals here, you can see the trends over the last 40 years. The forecast for this winter on the right side of that graph on the left, you can see quite a bit colder than last winter in terms of our HGD total forecast, but very much in line with the prior 4 winters. So from basically 2019-20 all the way through 22-23, overall a very similar outlook in terms of heating degree days. So if you're looking for recent years that could be comparable from a heating demand standpoint, those are 4 years that are very recent. That would be good years to use. On the right-hand side, you can kind of see how things are on a ranked basis. Notice there is kind of a nice distribution there, where there's 4 winters on the left that are pretty cold, 4 winters on the right that are extremely mild, and then kind of a block of the moderately mild and a nice block of moderately cold, kind of separated out there. So we're definitely in that moderately mild winter scenario here on the right-hand side. Not extremely warm like some of the recent years, but nonetheless, more warmth than cold for the winter season as a whole. You can see the breakdown there on a month-by-month basis of our current HGD forecasts. And again, note for the November through March period, February and March are the ones forecast to average at least closest to normal from a heating degree day standpoint, whereas the early winter period has the strongest anomalies on the warm side from a heating degree day standpoint. Now, looking at the precipitation outlook, we are in general forecasting more of the southern U.S. to average drier than average for the winter season. Northwestern U.S. as well as areas around the Great Lakes down towards the Tennessee Valley, more likely to see the above normal precipitation. But there is a lot of month-to-month variability. But generally speaking, the Northwest will stay fairly consistent on the wetter pattern, and the Southwest through Texas fairly consistent on the drier pattern. But areas from, say, the Central Plains into the Tennessee Valley will see a little bit more variability on a month-to-month basis. Looking at how that averages out for the entire December to February period, again, strong positive anomalies on the rain and snowfall across the northwestern U.S., and then also from the Great Lakes down into the Tennessee Valley. But notice very dry for California and the Southwest down through Texas into Florida. So we will likely see an expansion and increase in the intensity of drought across those areas as we progress through the winter season. Looking at how that translates to snowfall, that's always obviously a lot harder, especially across the southern half of the country, since snowfall normals are fairly low. But in general, we are expecting above average snowfall from the upper Midwest westward into the Pacific Northwest, with the Northern Rockies especially most likely to see the higher snowfall anomalies. But note, for the most part, the remainder of the country at or below average snowfall. So a lower snowfall total this year across the Sierra after a couple snowier winters, also below average snowfall for the central and southern Rockies, and note across the Northeast some stronger anomalies there, largely tied to below average lake effect snowfall totals this winter season. However, while we do expect there to be fewer lake effect snowfall events than usual, we are going to be seeing well above average water temperatures in the Great Lakes this winter season. So if we do see a major cold wave progress into the Northeast this winter season, the very warm waters combined with that cold air would provide the potential for a very intense lake effect snowfall event to occur. So even though we will see fewer events than usual and the overall total for the winter is likely to be below average, it's still quite possible we could see a high impact event take place at some point during the winter season, just given the very warm lake waters. So, and any cold air mass that comes through will be tapping into that abundant supply of warmth and moisture to produce some higher snowfall totals for a brief event at some point during the season. Also, below average or a reduced number of coastal storms should bring below average snowfall to most of the Mid-Atlantic and Northeast outside of the Great Lakes. Now, as we look into the renewable side of things, above average winds likely from the plains westward into the Rockies, especially the northern Rockies. Again, those areas will be seeing the most frequent storm systems passing through this winter season, so a lot more wind events as a result. But the southern U.S. in general seeing a quieter pattern this winter season, so reduced storm numbers, bringing less wind and also bringing less cloud cover in general. So the Southwest down through Texas, likely seeing more sunshine than usual this winter season, so helping the solar generation output in those areas as we progress through the season. Now, looking globally, you can see for the most part outside of the US, most of Europe and Asia are forecast to be warmer than normal this winter season. Now, there will likely be more variability than what's indicated there. It kind of hints at reduced warm anomalies across Scandinavia as well as eastern areas of Russia. So it's kind of hard to pinpoint where some colder air will be mixed in, but most likely it'll be at least a little bit more variability than indicated with that widespread warmth on the map. It's just kind of hard to pinpoint where any little pockets of cold might decide to show up during the winter season. But the bottom line is that the majority of the continents there are forecast to see, kind of like the eastern U.S., the majority of the winter coming in warmer than normal, and some cold waves likely happening here and there, but not enough to outweigh the generally warmer themes that will likely prevail for most areas. Rainfall and snowfall from the UK and Scandinavia eastward into Russia should be above average, but Southern Europe, Spain, across the Mediterranean areas, likely drier than average this winter season for those portions as we head through the next several months. Now, kind of summarizing things again here across the US, across the Northwest, that is really one area to kind of focus on for the potential for a lot of major winter storms coming in from the Pacific, bringing a lot of high winds, a lot of high rainfall and snowfall totals to the Cascades areas. So some higher impact events for those areas possible this winter season. So Seattle could see some impactful events, Portland as well. But farther south, California, after 2 consecutive snowier than average winters in the Sierra, this winter should see below average snowfall in the Sierra as well as the central and southern Rockies area. So that will result in reduced water supplies as we head into next summer in those areas, and also result in a further expansion of the drought that's developed in those areas this summer, and likely setting up the potential for increased wildfire risks as we progress through the season as well. Now, the north central US, again, likely to be coming in near to potentially below average this winter season, with more snowstorms than average as well. So snowfall totals in general should be above average for most areas there this winter season. But farther east towards the Great Lakes, where more warmth is expected this winter season, more of that precipitation could fall in the form of rainfall, and that in general will result in a wetter winter pattern, but not necessarily above average snowfall for some of those areas. And so in general, mild but potentially stormy for the winter season. Farther east towards the East Coast, most of the East Coast in general should see below average snowfall and above average temperatures. The one exception and kind of caveat to that is across the Southeast, where because the trajectory of cold air masses this winter season will likely, when they occur at least, come from Western Canada down through the plains and down towards the Southeast, there could be a more direct impact of that cold when it happens into the southeastern US. So even though cold air masses might be pretty limited, because of their likely taking a direct route towards the southeast, there actually is a higher than average risk for a freeze event in Florida this winter season. So there may not be very many cold days there, but the ones that do occur could potentially be cold enough to produce frosts and freezes down into the Florida peninsula. Now, kind of summarizing things here historically and how the winter season forecasts have fared from our standpoint. Comparing them at least to climatology as a forecast, the green lines there for December to February and November to March indicate from a heating degree day standpoint what your average error would be for the seasonal total if you use a 30-year average or the 10-year average as a forecast basis. So you can see in general, the DTN seasonal forecasts have provided a significant improvement in skill relative to just using the 10-year average as a forecast for the winter season. So definitely we have been consistently beating those tendencies over the last 13 years or so, at least going back as far as we have data to measure. Kind of summarize the forecast here. Again, a weak La Nina is the main driver for the winter season. So there's obviously some possibility that it could come in stronger than forecast, although it doesn't look likely. But in general, a stronger La Nina would likely increase the odds for more warmth across the southeastern US were it to occur. But that does not appear to be a likely scenario at this point. Our analogs and model forecasts do suggest, again, the potential for widespread warmth south and east, but potentially more cold across central and western Canada and the northern portions of the central and western US as well. And so we'll have to watch those areas for the potential to see more of the meaningful cold this winter. One thing that La Nina winters typically do feature are at least one or two major outbreaks of cold air that can be quite intense. And so even though the majority of the winter season across the eastern US should feature above average temperatures, we could see a meaningful shot of cold air happen, especially during February. But the first half of December also shows some tendency for historically at least, for similar winters to have an outbreak of colder air. So again, these don't tend to be very long-lived events that last for multiple weeks, but a week of very cold air, here and there during the winter season can still happen. That does bring some, sub-zero cold and widespread snowfall impacts across the country. Just in general, those will tend to be outnumbered by the milder, quieter weeks for much of the central and eastern U.S. In terms of precipitation, again, the northwestern U.S. being the primary focus area for the bigger storms this year. And those will tend to track across the northern tier of the central U.S. as well. So the Dakotas up to Minnesota, those areas could see quite a few impactful winter storms. However, that storm track will tend to keep most of the snowfall kind of confined farther north and west than usual. And so the East Coast and Northeast, less snowfall than usual across those areas, and also less lake effect snowfall than usual in general. So we kind of look at some industry specific impacts here on the utility side. Again, obviously with the warmer weather, below average heating demand and in general power demand across much of the southern and eastern US this winter season. But do be aware again with the pattern we likely will see this year, a couple short-lived but very intense rounds of cold are quite possible. So into the Midwest and Southeast, we could see some meaningful spikes of demand that occur. They just likely won't last for multiple weeks at a time, but a couple of weeks here and there during the winter season could see some significant cold anomalies that do stress systems at least temporarily. Also, again, a reduced threat for winter storms along the East Coast. So the big coastal storms that bring the high winds, the heavy snow and rain, coastal flooding, those types of events will be less frequent than normal this winter season along the East Coast. But again, a higher impact threat from the upper Midwest westward into the Pacific Northwest. On the aviation side, we are expecting, again, an enhancement to the jet stream across the northern US. So flight times will be impacted by the stronger winds across those areas. So west to east flights being faster than usual, east to west flights slower than usual, given the enhanced wind speeds across those areas. Also, the enhanced storm track across northern US will likely result in more impacts to airports, both from cloud cover and precipitation to snow and icing events. So kind of Chicago, Detroit westward into the Pacific Northwest, likely seeing the bulk of those impacts. But at the same time, southern airports like Atlanta and DFW and Charlotte should be seeing fewer storm impacts this winter season and more days with clear conditions, and overall fewer aviation impacts in general across the southern US this winter season than usual. On the transportation side, the big impact here will be across the Northeast in terms of lack of impacts. Reduced snowfall this year will result in just reduced snow clearing needs, reduced chemical usage in those areas, and reduced frequency of lake effect snowfall events around the Great Lakes, also helping to ease the burden on local departments in those areas for snow removal. But again, because the lakes will be very, very warm this winter season, if we do see a big cold wave, we could still see a very high impact snowfall event take place at some point during the winter season downwind of the Great Lakes if we can time a meaningful cold wave, especially during the first half of the winter season when the lakes are at their warmest. So we'll have to watch for that. But in general, just fewer events than usual this winter season, resulting in the below average total for the winter season as a whole. Again, the Northwest will be the primary area to really focus on for the big time snowfall events, as well as across the upper Midwest from Minnesota westward. Also, these types of winters do tend to see an enhancement of severe weather. So severe thunderstorms and tornadoes and those kinds of things will be an increased risk as we head towards the second half of the winter season, especially February and March, across the Tennessee Valley and the lower Mississippi Valley. So Gulf Coast region in general will have the potential for an enhancement of severe weather impacts late in the winter season. Now, looking offshore, especially in the Gulf of Mexico, with the La Nina pattern this year, we won't see as many cold fronts pass through the Gulf of Mexico, so there won't be as many days that have high winds and high seas. as a result of that. However, the ones that do occur will likely be very intense. And so while there may not be very many periods that see the high seas and winds, the few that do occur could be quite robust across the northern Gulf Coast and could be quite impactful. At the same time, along the East Coast, with fewer coastal storms than usual, most of the East Coast ports should see overall a fairly favorable winter in terms of shipping in and out of those ports, with fewer days with high winds and high seas for pretty much the entire East Coast relative to normal. However, the quieter conditions across the Gulf could also result in more days this winter season where we do see sea fog. And so that could be the bigger impact for the northern Gulf ports this winter season, with more days, especially late in the winter season, where we do see quite a bit of sea fog that could be impactful for ports in terms of getting ships in and out of those areas because of visibility conditions. So finally, we'll kind of just again summarize things here and then open things up for questions. The bottom line, again, is a milder winter than average across the southern and eastern US. But there could be, again, a couple intense cold waves. But for all the cold and snow, kind of look towards the upper Midwest, towards the Pacific Northwest. Those will be the high impact areas this winter season, the way it looks right now. So anyway, Nate, have we seen any questions come in so far that we can take a handle on?
Absolutely, Steve. We do have a few questions that have come in, and the first one is regarding freezing rain or icing conditions. Do we expect that to be a large impact this winter?
So one thing that is interesting with some of these La Nina winters across the southern U.S. is that there have been some of them that have had some impactful events in that regard in terms of ice or snow, from Texas into parts of the Southeast. Obviously, the biggest event we can all recall, obviously, is February 2021. That was also a similar weak La Nina year. And so in general, those aren't very common events, but there have been several of those that have occurred. So if we can get one of these brief cold waves to team up with a storm system at the same time across the southern U.S., we'll have to watch for that kind of impact across Texas and the South in terms of getting a freezing rain scenario that could be impactful to utilities and transportation in those areas. Farther north, kind of that area in between might be an area to look for an enhancement of freezing rain risks. Farther, as we get towards the upper Midwest and Northwest, we'll see predominantly more snowfall impacts, but that area in between, farther east, where you're kind of on that borderline of the cold air, we could see some shallow cold Arctic air events that do bring some icing events, possibly to Chicago or places like that this winter season. So we'll have to watch for that as we progress forward in time here. So just because we may see below average snowfall for a lot of areas, it only takes one outbreak of shallow Arctic air to set up a favorable pattern for freezing rain event for many areas across the central U.S. And certainly a risk we'll have to watch for this winter season.
Yeah, definitely. And what makes it worse sometimes is if it's been warm for so long and you haven't seen one for a while, then it just suddenly have an onset and temperatures drop really fast. A lot of people aren't used to them, so it may have a little bit more impact on people and things than it usually would if you were getting them a lot, or you're more used to them. So it's definitely something to keep a close eye on this winter. Next question. What are the chances of a cold shot similar to the last 2 years, and what would cause an event like that in December? I think I can take this one. The chances are relatively good. I mean, this outlook has been warm dominated. We were talking about how warm it's going to be, but all other things we've been talking about is the potential for some sharp, rather albeit short-lived cold shots. So yeah, we do anticipate it to come in sometime. We think the best chances overall will be late in the winter. It will be February, somewhere in there. It would be the best chance, and we think that just because of the way that the analog suggests that the polar vortex will behave. So a strong polar vortex earlier in the season makes it a lot more difficult to get the cold to come down overall. However, there are things that can cause it outside of that impact. For example, let's say if something in December, if we get the Madden-Julian oscillation or the MJO to go far enough into the Pacific with enough strength, we could, that's the type of thing that can flip the pattern cold temporarily, and that could occur in December overall. And one thing about the MJO this season so far is the fact that it's been pretty active through the fall and it's been pretty fast moving. So at least we're going to have some opportunities this winter to have the MJO wave get into that Western Central Pacific region, especially your phases 7, 8, and into 1. We could get it to, with any kind of strength. That's the kind of thing it takes to flip a pattern. And if we could have some sort of typhoon that recurves into the jet stream in the Western Pacific, if it can occur at a similar time and add some amplification to the pattern, that's one way we could get a cold air mass to occur across the even the central and eastern part of the country, or really could end up anywhere depending on how the pattern sets up. But better chances for that would be in the northwest and north central part of the country. So those are the types of things that could happen that could get things a little bit colder in December. It's just that the odds of it are somewhat less than normal this year based on the way the polar vortex is setting up so far this season. But something we're watching in December that could easily occur, because some of our analog years and La Nina years, you can get these quick cold shots, but warm dominated with many days, but these short cold shots certainly possible. Next question. How far below normal will California precipitation and snowfall be? Will it be like really dry or just a little bit? What do you think, Steve?
Well, certainly the overall storm track this year will tend to favor the majority of those storms going into the Pacific Northwest. However, one thing we have to watch for is that because we do have still a lot of warmth in the Pacific outside of, it has cooled off in the equatorial areas, but north of the equator, there's still a lot of warm water in the central Pacific. And so that does provide an enhancement in moisture supply. So, we could still see one of these atmospheric river events take aim at California at some point during the winter season that really kind of help to make up the overall season deficit more than currently expected. So while it does look to be a fairly dry winter in California this winter season, because the water is so warm in the central Pacific north of the equator there, we do have the potential for a lot of these storm systems that do come in to have a lot more moisture with them as well. So, if we can get one of them to hit California this winter, and you get one of those strings of 3 or 4 days where you just get an epic, blast of snow in the Sierra, that could occur, and then really kind of mitigate the overall dry winter regime. We've seen some of that. We saw that happen last year, and obviously it happened multiple times the previous winter. So, it's just one of those things where most of the storms will likely be north of there, but because the storm systems that move into the coast will likely be amply supplied with moisture, if we can just get one big one to hit California, it may end up making it be at least a little bit closer to average in terms of rain and snowfall, and not as severely dry as it could otherwise be. So, that does at least provide some hope for the season not being, horribly dry across California this year.
That makes a lot of sense. It's kind of like a lot of other things we're talking about. Dry dominated, but again, short periods can make a big difference and have some large impacts. All right. Got some comments, some questions regarding the Northeast for snow. There's been last winter has been rather bleak for snow for a lot of places, along the I-95 corridor in particular. And you think it'll be quite the same this winter, or you think maybe they'll get a little bit more or less? And I think I can take that one. As far as the Northeast urban corridor this winter, it's probably going to be a lot of days where not a lot of, it'll be warm, very warm, very mild, too warm to snow. And that is going to take its toll. So when we say below average snowfall, we're saying it because that is what we expect. It's going to be very difficult to make up to seasonal averages, especially the further north you go, like the mid-Atlantic or something like Washington, D.C., Philadelphia. It could be a little bit easier because the average is a little bit lower. But for places like Boston or Albany or Portland, Maine, just for example, or even New York City, the averages are a little bit higher. So you need multiple events to get there. So what we think is going to happen this winter is that it'll be warm dominated, be very, and some of the events that come in there will be rain, However, there will be opportunities in these short periods to get these type of snowfall events, even a coastal storm that could sneak in there. So even though the season might end up with less snow than average, a couple of high impact events, I would probably think that's going to happen. Especially if we can get any kind of polar vortex disturbance to take us away from this typical La Nina pattern that makes it so warm during the short stretches. I mean, those types of events will be possible. So it'll be something you have to stay awake and keep an eye out for during the boring periods this winter.
Right, and of course too, with the very warm waters in the Atlantic this year, that kind of tends to skew that risk for a meaningful snowfall event, more into the second half of the winter season once those waters cool down, and maybe kind of hard to get those coastal areas snowy during the early part of the winter season with the very warm water. But yeah, certainly a big impactful event, not out of the question at all for the Northeast, but just not very many of them.
Yeah, that makes perfect sense. All right, next question. The set of questions are more Midwest based. So, what about places like the Ohio Valley, Chicago, Milwaukee, Great Lakes, or like Central Great Lakes? They didn't get a whole lot of snow there last winter. Do you think they'll have any hope this winter?
Yeah, I'll talk on that. Looking at some of the analogs, there were a number of years where there were at least one or two impactful periods in those areas. Like you can look at a year like the 98, 99 La Nina. That was a stronger La Nina, but that winter season was a warm winter for most of those areas. But there was a 10-day period in the first half of January that year that saw record cold and snow in Illinois, for example. And so the rest of the winter was pretty uneventful, but you had one period in there where you had multiple storms and a lot of cold air and a lot of high impact events. And so with the again, if we can get the polar vortex to cooperate and play to adjust the jet stream far enough south to shift that storm track from the upper Midwest down into the Ohio Valley for a week or two, then yeah, those areas could see a period of high impact storm events this winter season in terms of snowfall. But the majority of the time, the storm track will be farther northwest, and they will tend to be on the warmer, rainy side. But we could see some of these events this year where you have a period of snow and freezing rain that transitions to rain across, like Michigan and Ohio, ahead of some of these storm systems. So sometimes you get kind of one of those winters where you see a lot of the sloppy transitional type of winter weather events where you get a little bit of snow and ice and that goes over to rain, and you don't get the big snowfall totals, but you do still have sometimes these kind of more nuisance events that can still occur on a regular basis. So that might be something to look for in those areas like in Detroit and places like that, where you could see a lot of minor rain to snow or snow to rain events that could still be impactful to various DOTs and so forth in those areas, even though the overall snowfall totals will be fairly low for the winter season as a whole.
Excellent. A couple more here for the top of the hour. We'll have to go. First deals with Pacific Northwest and southwestern British Columbia. So we'll talk a little bit about maybe Western Canada, what might happen up there. And I think I can take that one. For Pacific Northwest and southwestern British Columbia in general, I think a more active storm season is coming, and you'll have to be on the lookout for some of these higher impact ones with stronger winds. So that's something you'll have to be on the lookout for with at least one or two of these systems. And the lower temps and higher precip, that will probably mean a lot more rainfall, but some snowfall even in the lower elevations for some of these isolated events if we can get some Arctic air in there. But during these warmer October periods that transition to the warmer winters, it's usually less in the way of Arctic air overall speaking, and more just cooler air that's caused by clouds and precipitation. So even though during the short stretches there could be some snow in the lower elevations of the Pacific Northwest that typically are rainy, you'll have a little more rain than normal. I mean, it could mean some flooding late in the season in a few spots, so have to watch out for that. But I wouldn't expect there to be a ton of low elevation snowfall, but there will be some events that could be significant. And last one, something we haven't touched on. What about the tropics? Are we done with the tropical season? It's been a very weary season so far, and the water is very warm out there. Do you think we have anything more to worry about on that front when we put that to bed for the winter? Or is it, we have to watch out for some late season stuff?
Yeah, I guess I'll talk on that. I mentioned briefly earlier the very warm water in the Western Atlantic. The Gulf also is very warm. The pattern as we head into winter here is going to kind of favor infrequent shots of cold air into the Gulf and off the East Coast. So it's going to be harder to cool down that water, during the early part of the winter season. So it's not out of the question we will see some additional storm impacts. Obviously, as we get later in the winter season and the jet stream goes farther south, most of the storms that develop are ones that develop down in the Caribbean that move into Central America, or if they go farther north, they just get sent out to sea and don't directly impact the U.S. But we still have a period of time here for the next few weeks where something could get pulled up out of the Caribbean towards Florida, or develop in the Gulf itself, because we haven't really cooled the water down there yet with the very warm, persistent pattern that we're in at this time. So as long as we keep the warm water in place there, the tropical risks will continue. So I'll expect that we'll see a few more storms as we progress through the remainder of the season, and maybe one of those is a threat to the U.S., especially Florida. Obviously, as we go past the say early part of November, most likely any storms that develop will not be a threat to the U.S. coastline, but could impact the Caribbean or just the middle open areas of the Atlantic Ocean as they head northeastward.
Makes a lot of sense. If we're looking at we talk about the MJO, a favorable period for some storms could be early November. As the upward motion goes across that region, it could get the Caribbean storms fired up a little bit, but I think by the time we get to mid-November, get a little bit of a break, so we could time it out a little bit. But as you said, something that we have to watch pretty closely into well into December, even with all that warm water out there. So definitely something we can't put to bed just yet. But I think that is all the time we have for questions today. Andrea, can you close us out, please?
Yes, thank you, Eric, Nate, and Steve, for a really informative Winter Outlook webinar. We have recorded this webinar, so we will be sending out the recording when it is ready to everyone who registered. With that, I hope everybody has a great day and a great rest of your week. Thank you.